Hello, welcome to today's class. In today's class, we will talk about uniform cost search algorithm, which is another type of uninformed search. In the last class, we talked about the breadth first search algorithm, and we saw that BFS do not always return the optimal solution. And we looked at this example where we had two goal nodes, H and I, where H is at a depth of 2 and I is at a depth of 3, and the path cost to H is 6, whereas the path cost to I is 3. And since we know that BFS always returns the shallowest goal node, in this case BFS will return the solution H, which happens to have a greater path cost than the other possible solution, and hence BFS may not always return the optimal solution. It's not optimal. So BFS do not return the optimal solution when the path cost is not a non-decreasing function of the depth of the node. So what do we mean by this? Here H has a depth of 2, but it has a path cost of 6, whereas I has a depth of 3 and it has a path cost of 3. So here we have a node whose depth is more, but its path cost is less compared to another node whose depth is less compared to I. So in this case, we cannot say that as the depth is increasing, the path cost is non-decreasing. It's not the case that it is non-decreasing, it is decreasing in case of I. In case of I, as we increase the depth, the path cost is actually decreasing. But the condition is that it should not be non-decreasing. If it decreases with depth, then BFS will not return the optimal solution. So however, if the path cost is a non-decreasing function of the depth of the node, then BFS will return the optimal solution. So as we increase the depth, if the path cost is non-decreasing, then BFS will return a optimal solution. For example, here again we have two goal nodes, but in this case the path cost is a non-decreasing function of the depth of the node. So we don't have any nodes whose depth is more, but its path cost is less compared to another node whose depth is less. So in this case, in this example, BFS will again return the solution, the shallowest goal node as the solution. So it would again return H as the solution, but now H is optimal solution because its path cost is only 3, whereas the path cost of I is 7. So in this case, BFS will return the optimal solution, and we are getting the optimal solution because the path cost is a non-decreasing function of the depth of the node. A special case of the above is when all the step costs are equal. So what do you mean by that? As you can see, all the step cost in this case is 1. So whenever we move from one node to another, the cost involved is 1. So all the step cost is 1, hence they are equal. And in this case, your path cost will be a non-decreasing function of the depth of the node. As we increase the depth, the path cost will always increase actually. And for such cases also, BFS will return the optimal solution. Now, uniform cost search, it is optimal for any step cost function. So unlike BFS, which is optimal only in certain condition, uniform cost search is optimal for any step cost function. And in uniform cost search, instead of expanding the shallowest node, uniform cost search expands the node n with the lowest path cost Zn. So what do we mean by this? We'll look at one example. It will be more clear then. So it's not always the case. It's not the case that we select the shallowest node for expansion in the next step. Nodes are selected for expansion based on a path cost function Gn. And this is done by storing the frontier as a priority queue ordered by Z. In case of BFS, the frontier list is maintained as a FIFO queue. However, in uniform cost search, the frontier list is maintained as a priority queue ordered by Z. Again, it will be clear as we look at one example. And another one more difference between uniform cost search and BFS is that the goal test is applied to a node when it is selected for expansion rather than when it is first generated. Yet one more difference is that test is added in case a better path is found to a node currently on the frontier. So let me explain all this using one example, and we will take the same example where we need to find a route from Arad to Bucharest in this given map. So our starting node is Arad. That comes from the problem description. So Arad is our initial state, and as we mentioned, the frontier list will now be maintained as a priority queue. Our initial node, we will put it to the frontier list to start with. Our explored set will be empty list to start with. And next, from the problem description, we find out what are the possible actions for Arad. And the valid actions are that we can go to Zenind, or we can go to Timisoara, or we can go to Sibiu. So if our current state is Arad, then these are the three possible actions. So now for each of them, we will generate a node because none of them are in the explored set. Neither they are in the frontier list. So nodes will be generated for Zenind, node will be generated for Timisoara, and node will be generated for Sibiu. And now if you look at the map, you will see that the distance from Arad to Zenind is 75, and the distance from Arad to Timisoara is 118, and from Arad to Sibiu it is 140. And that's your function Z, which gives us the path cost. So G for the node Zenind is 75, Z for Timisoara is 118, and Z for Sibiu is 140. So this the path cost function tells you what is the cost from the starting state to a given node n. And now When we compare this path cost, we see that the path cost of Xerin is the lowest, followed by Timisoara, followed by CBO. And hence, these three nodes will be entered into the frontier list in this order. Since it is a priority queue ordered on the value of Z, the node with the smallest Z value will be at the front of the list, followed by the next smallest value, the node having this next smallest value, and so on. So as you can see, Xerin has the lowest path cost, so it would be at the front of the list, followed by Timisoara and then by CBU. So this is what we meant when we said a priority queue ordered on Z. Next, we need to select the next node for expansion. So since Xerin is at the front of the list, Xerin will be selected. So Arad has already been explored, and now Xerin we remove from the frontier list. We put it in the explored set. Next, we try to see what are the valid actions and when our state is Xerin. So if our current state is Xerin, the valid actions are we can go to Arad or we can go to Oradia. And now Arad is already present in the explored set. So if the new node is already present in the explored set, a node will not be generated for it. However, Oradia is not present in the explored set, neither it is present in the frontier list. So we'll generate a node for Oradia. And now if we look at the map again, the distance from Xerin to Oradia is 71. And now we need to compute the Z value for Oradia, Timisoara and CBU. The path cost to Oradia will be 75 plus 71. So what is the path cost from the start node to that given node? So in case of Oradia, the cost will be 75 plus 71, which is 146. For Timisoara and CBU, the values will not change. They will remain as it was before, 118 and 140. And now if you look at the Z value of these three nodes, we say the lowest is 118, Timisoara. So Timisoara will be at the front of the frontier list, followed by CBU and followed by Oradia, because that's the order. And now we need to select the next node for expansion. And we will select Timisoara. And again, I did not mention it for the previous two nodes, but I will mention it now. As we select a node for expansion, we check whether this node is the goal state. Now we are selecting Timisoara for expansion, and since this is not our goal state is Bucharest, so we will add Timisoara to the explored set, and then we'll try to find out what are the valid actions in this state. The two valid actions are we can go to Arad or we can go to Lugos. And Arad is already present in the explored set, so no new node will be generated for Arad. However, for Lugos, a new node will be generated. And again, if you look at the map, the distance from Timisoara to Lugos is 111. And now we again need to calculate the Z value. The G value for Lugos will be 118 plus 111, which is 229. For the other two nodes, nothing has changed, so they remain as 140 and 146. And this is the order for the G values. The G value of CBU is the lowest, followed by Oradia and Lugos. So the nodes in the list will be in this order: CBU followed by Oradia followed by Lugos. And now we need to select the next node for expansion. So we'll select CBU because it is the lowest G value. It is at the front of the list, frontier list. And as we select CBU, we remove it from the frontier list. And then we check whether this is the goal node. It is not the goal node. Our goal node should be Bucharest. And hence we enter CBU to the explored set. And then we look at what are the valid actions in this state. So in this state, we can, so from CBU we can go to Arad, or we can go to Oradia, or we can go to Rimniku, or we can go to Figueres. Now Arad is already present in the explored set, so no new node will be generated for Arad. However, Oradia is present in the frontier list. So this is the first case that we see, and that the node that we are trying to generate is present in the frontier list. In case of BFS algorithm, even if the node that we are trying to generate is present in the frontier list, we did not generate a node for it. But in case of uniform cost search algorithm, it's slightly different. If the node is in the explored set, we don't generate a node for it. However, if that node is present, it's not present in the explored set, but it's present in the frontier, then we have to handle it slightly differently. Rimniku and Figueres, they are not in the explored set, they are not in the frontier list. So the two nodes are generated for Rimniku and Figueres with the path cost, with the step cost of 80 and 99. And for Oradia, we'll now consider the path from CBU to Oradia also. So this is slightly different from the BFS algorithm. So you have to consider this path from CBU to Oradia also, even if Oradia is already present in the frontier list. And now the step cost from CBU to Oradia is 151. So now we have to compare the two paths that we have to Oradia. One path, two paths starting at the start node. So our start node is Arad, and one path to Oradia is from Arad we go to Gerind, and then we go to Oradia. So that is one path. The second possible path is from Arad we go to CBU, and from CBU we go to Oradia. So these are the two paths from Arad to Oradia. And now we will compare the path cost, the two path cost. For the first path from Arad to Gerind to Oradia, the path cost will be 75 plus 71, which is 146. Whereas for the second path, Arad to CBU and then CBU to Oradia, the path cost will be 140 plus 151, which is 291. Since the original path has a lower Z value, lower path cost, we will keep the original path and we will not consider the new path. So this is the path with the lowest Z value. So this will be preserved, whereas the new path will be ignored. So this new path has been ignored. And now for these four frontier list nodes, we have to calculate the Z value. The G value for Oradia is 146. For Lugos, it's 229. For Rimniku, it is 220. And for Figueres, it will be 239. 140 plus 99 is 239. And now if you order the node based on the z value, we see that Oradia has the lowest, so it will appear at the front of the list. This is the order. Oradia is the lowest, followed by Rimniku, followed by Lugos, followed by Fagras. And hence, this is the order in which the node will appear in the frontier list, because it's a priority queue. And now when we select the next node for expansion, Oradia will be selected. First we check whether it is a goal node. It is not a goal node. So if it is not a goal node, then we enter it to the explored set, and then we consider what are the valid actions in this state. The two valid actions are, we can go to gerund or we can go to CBU, and both these nodes are already present in the explored set, and hence no new nodes will be generated for Oradia. And we have to select now the next node, and the next node will be Rimniku. So Rimniku will be selected for expansion, and we first check whether the selected node is the goal node. No, it is not the goal node. If it is not the goal node, we will add that node to the explored set, and then we'll try to find what are the valid actions. The valid actions, we can go to CBU, we can go to PTSD, or we can go to Craiova. And among these three new nodes, CBU is already present in the explored set. The other two nodes, PTSD and Craiova, they are not present in the explored set, they are not present in the frontier list also, and hence the new nodes will be generated for them along with the path cost, although the path cost is missing here. And now we need to calculate the z value for the nodes in the frontier list, like Lugos, PTSD, Craiova, and Fagras. For them, I have to calculate the z value. And if you calculate the g value, we'll see that the g value for Lugos is 118 plus 111, which is 229. For Fagras, it will be 239. For PTSD, it will be 140 plus 80 plus 97, which is 317. And for Craiova, it will be 140 plus 80 plus 146, which is 366. And if we order the nodes based on the g value, this is the order: Lugos followed by Fagras, followed by PTSD, followed by Craiova. And hence in the frontier list, this is the order in which we'll have the nodes. And now when we need to select the next node for expansion, Lugos will be selected for expansion. Again, we check whether this selected node is the goal state. No, it is not the goal state. So add it to the explored set, and then find out what are the valid actions. The valid actions are, we can go to Timisoara or we can go to Mehadia. Timisoara is already present in the explored set, so no new node will be generated for it. However, for Mehadia, it's not present in the explored set, it's not present in the frontier list, and hence a new node with the step cost of 70 will be added. And now we need to calculate the g values again, and the g values are as follows, as you can see. And now the order is Fagras followed by Mehadia, followed by PTSD, followed by Craiova, and hence this is the order in which the nodes will be present in the frontier list. And hence the next node that will be selected for expansion is Fagras. And we first check whether Fagras is the goal state. No, it is not the goal state, so Fagras will be added to the explored set. And we'll find out what are the valid actions for Fagras. The valid actions are, we can go to CBU and we can go to Bucharest. So CBU is already present in the explored set, so no new nodes will be generated for CBU. However, Bucharest is not present in the explored set. It is not present in the frontier list, and hence a new node will be generated for Bucharest. And the difference and hence here we see one difference between BFS and uniform cost search. In case of BFS, we check whether when a node is generated, we check whether it is a goal state or not. So in case of BFS, we would have, at the time Bucharest is generated, we would have checked whether this new node is a goal state, and if it is a goal state, we would have stopped our search and we would have returned the solution. But in case of uniform cost search, we don't check whether a node is a goal state or not at the time the node is generated. We check whether a node is a goal state or not only when it is selected for expansion, not when it is generated. So that's one difference between BFS and uniform cost search. So we have added a new node for Bucharest, and now we have to calculate the G values. And the G value for Bucharest is 140 plus 99 plus 211, which is 450. And if you order the nodes, the 4 nodes in the frontier list based on the G value, and this should be the order: Mehadia followed by Pitești, followed by Craiova, followed by Bucharest. And that's the order in which they will be present in the frontier list. And if we now select the next node for expansion, Mehadia will be selected. And as we select a node for expansion, we check whether it is the goal state or not. It's not goal state, and hence we will try to find out we add the Mehadia to the export set, and then we find out what are the valid actions. And the valid actions are that we can go to Drobeta or we can go to Lugos. Lugos is already present in the exploit set, so no new node will be generated for it. However, Drobeta is not present in exploit set, it's not present in the frontier list, so a new node will be generated with the step cost of 75. And now if we calculate the G values, and the G value for Drobeta is 374, and hence this is the order of the nodes based on their G value, and hence this is the order in which the nodes will appear in the frontier list, which means the next node that will be selected for expansion is Pitești, and we first find out whether the selected node is the goal state or not. It is not the goal state, so we add it to the export set, and then we find out what are the valid actions. The valid actions are: we can go to Râmnicu, we can go to Craiova, or we can go to Bucharest. And now we can see that Râmnicu is already present in the export set, so no new node will be generated for it. However, Craiova and Bucharest, they are not present in the export set, but they are present in the frontier list. And as we have seen earlier, in case of Oradea, whenever the nodes are present, the nodes that we are trying to generate, they are present in the frontier list, then we have to handle this case slightly differently. So as you can see, for Pitești, no new nodes will be generated because Râmnicu is already in the export set, and Craiova and Bucharest, they are already there. But we have to consider the new path that we are exploring. So we have a path from Pitești to Craiova, and we also have a new path from Pitești to Bucharest with the step cost 138 and 101 respectively. So now we have to consider this new path also, and if we consider Craiova first, we have two paths from the start node Arad. The first path is Arad to Sibiu, then to Rymniku, then to Craiova. That's one path. And the other path is Arad to Sibiu, then Rymniku, then Pitești, and then Craiova. So two different paths from Arad to Craiova. And the path costs are 366 and 455 respectively. So among these two paths, the best is Arad to Sibiu to Rymniku to Craiova, and hence we will keep that path and we will discard the new path that we have found. And for Bucharest, we have two different paths. One path is Arad to Sibiu to Figueres, then to Bucharest, and the other path is Arad to Sibiu to Rymniku, then Pitești, and then to Bucharest. And if we try to find out the path cost for these two different paths, we will see that the path from Arad to Sibiu to Figueres to Bucharest has path cost 450, whereas Arad to Sibiu to Rymniku to Pitești then to Bucharest has path cost of 418. So this is a special instance that we have seen. The new path is actually having lower cost than the earlier path. So we will discard the earlier path, which is from Figueres to Bucharest, and instead we will preserve this new path from Arad to Sibiu to Rymniku to Pitești to Bucharest. And this is what results in uniform cost to return optimal solution, because the earlier path that we had discovered was suboptimal, and if we discover a new optimal path, we discard the earlier path and we try to preserve the new path, and this makes uniform cost optimal actually. So in this case we had discarded the earlier path that we had discovered from Figueres to Bucharest, and we have replaced it with a new path from Pitești to Bucharest. So now we have to calculate the G values for the node in the frontier list, and the G value are 366, 418 and 374 respectively. So the order is Craiova followed by Drobeta followed by Bucharest, and hence this is the order in which they will appear in the frontier list. And now the next node will be selected is Craiova, and for Craiova first we check whether it's the goal state or not. It is not the goal state. Then we try to find out what are the valid actions. The valid actions are, we can go from Craiova to Drobeta or we can go to Pitești. Pitești is already present in the export set, so no new node will be generated. However, Drobeta again is not in the export set, but it is in the frontier list. So we have to consider the new path from Craiova to Drobeta, which has a cost of 120. And so now we have two paths from Arad to Drobeta. These are the two paths. The first path has a cost of 374, and the new path from Craiova through Craiova has cost 486. So the earlier path that we had discovered is actually more optimal in case of Drobeta. So we'll keep that one and we'll discard the new path that we had discovered. And now if we calculate the Z value, the G value will result in Drobeta having the smaller value from Bucharest, and hence the next node that will be selected will be Drobeta. First we check whether it's goal state. It's not the goal state, so we add it to the explored set, and then we find out what are the valid actions for draw beta. From draw beta we can go to Mehadia or we can go to Craiova, and both these nodes are already present in the explored set, so no new node will be generated for draw beta. And the next node in the frontier list, we had only one more node in the frontier list, so it will be selected, and we check whether the selected node is the goal state. Yes, it is the goal state, so we have reached the goal state, and hence we will return the solution Arad to Sibiu to Rimniku to Pitești, then to Bucharest. And this solution we will obtain by following the parent node. By following the parent link, we can find out what is the solution path. And uniform cost search actually return the optimal solution. We discarded the path through Figueres, which was suboptimal, and instead we returned a optimal solution with a path through Pitești. Although it has more number of node on the path, but it's more optimal. So it's not the shallowest path, but it's the most optimal path. Here is the algorithm for uniform cost search. So we have the problem as the input, and from the problem we find out we know what the initial state is. So we create the node for the initial state, and we add that node to the frontier list, and the frontier list is nothing but a priority queue ordered by the path cost, the G value. So initially, in case of our example, initially in the frontier list we will only have Arad, and our explored set will be an empty set. And then we have a loop, and this loop will continue for different conditions. One way we can exit from the loop is if the frontier list becomes empty. If we exit because of this condition, it means that we couldn't find a solution. The frontier list will become empty only in that case where a solution do not exist. If the frontier list is not empty, in that case we will pop. We'll take the first node from the list, and as you can see in this algorithm, when the node is selected for expansion, at that point we check whether that node is the goal node or not. So when the node is selected for expansion, we check whether it is the goal node or not, and if it is the goal node, we return the solution. So this is another way we can exit from this loop when we found a solution. However, if the node is not a goal node, then we add the node to the explored set, and then we find out what are the valid actions possible for that node, and for each of the valid action we generate a node, and this generated node, if it is already we will add that generated node to the frontier list only if it is not already present in the explored set or in the frontier list. So we'll generate the node, but we will add it to the frontier list only if it is not already present in the explored set or the frontier list. However, if the child node is present in the frontier list but not in the explored set, in that case we will check whether this new path is a more optimal one than the earlier path that we had. If the new path have less cost, then we will replace the earlier path with the new path. So that's the algorithm for uniform cost search, and we have seen these steps in our example. And that's all that I have for today's class. So I'll end today's class here and we'll meet again in the next class. Thank you. Bye.